Hello everyone, and today is our introduction to calculus. And so in calculus, we have two main operations, derivatives and integrals. And as you might have guessed, they are opposites of one another, just like how addition and subtraction are opposites from one another. So I have this formula over here. The derivative, d over dx, means the derivative of the function x to the power of n, where n is any real number, is equal to n times x to the power of n minus 1. And I'm not going to go over why that's true. We're just going to use this formula in the video. So I have two problems here. The first one is to find out the derivative of 3x plus 6. So using this formula over here, we're going to do just that. One pretty helpful property of derivatives and integrals is you can actually separate them. So this is going to be equal to d over dx of 3x plus d over dx of 6. So addition and subtraction can be separated for derivatives and integrals. The next thing we can do is actually, for multiplication, take these outside. So I can rewrite this as 3 d over dx of x plus d over dx. And you notice there's no x here. So you might be wondering, how does this formula help us? Well, I can actually rewrite this as 6 times x to the power of 0. Now this formula applies. So what we can say here is this is going to be equal to 3 times, here n is 1. So what we're going to get is, well, it's going to be multiplied by 1 times x to the power of 1 minus 1, which is just 0. And anything to the power of 0 is just 1. So this whole thing is just going to be 1. Next, we're going to add d over dx 6 times x to the 0. So for the 0, we're going to plug that in. So we'll have 6 times 0 times x to the power of 0 minus 1. So this is negative 1. And so what we'll actually have here then is 1 over x. But anything times 0 is just 0. So this whole thing is actually just going to become 0. And we're going to be left with 3 as our final answer. Okay. Moving on to the next problem. The first thing we want to do is establish a formula for the integral. Now, I said that these are inverses, sort of inverse operation, opposite operations, so we can use that to our advantage. We do know this already. So if I were to integrate both sides, the integral and the d over dx, right, these would cancel out. Just like that. And now I'll integrate this side as well. Now what I can do is say n is equal to t plus 1, because we want this formula sort of generalized for, the integral of x to the n, right? So by doing this, this means that n minus 1 is equal to t, so we can get the t in there. So we'll have x to the t plus 1 is equal to, remember, we can take this outside, t plus 1 integral of x to the t dx. Now you might notice I'm also writing dx after every integral, and that's just standard notation. This tells you what you're integrating with respect to. Same thing with this over here. It tells you what you're differentiating with respect to, because as you can see, there are multiple variables, right? There's an n. If we're differentiating with respect to n, completely different answer, right? Now we're going to isolate for the integral because that's what we want. So we can just divide both sides by t plus 1. And we have our general formula here. So we can go back and use this to solve this problem over here, the integral of 3x plus 6. I'm going to do exactly what I did here and separate it into the integral of 3x dx plus the integral of 6 dx. I'm also going to take this outside, like that. Okay, now we know the integral of x dx, right? It's going to be this. So we're going to have 3 times x. Our t here is equal to 1, so we're going to have squared over 2 plus, and this is 6. Remember, this is really 6. This is really 6 times x to the 0. So we're going to plug in 0 here. We'll have x to the 0 plus 1 is just x over 0 plus 1 is just 1, which is the same thing as just 6x. So in the end, we're going to have 3 over 2x squared plus 6x. And whenever we have indefinite integrals, what that means is there's nothing written like here or here, no bounds. You're going to write plus c. Because technically, if we were to differentiate this, as we've established before, when you differentiate what's called a constant, in this case we differentiated 6, right? We just got 0. If that was 7, you'll get 0. If it's 10, if it's 100, it'll always be 0. Which is why this constant c can be anything. And so this is our final solution to the problem.